So today, uh, I'll be talking about recursion. I'm still waiting on to see if more people will join or not. So yeah, I'm waiting like another minute or so. Okay. Just a quick debrief and introduction. So, last week, or last class, or whatever, I introduced a possible assignment of creating a tic-tac-toe game with methods for displaying the board and evaluating if the game has been won. Uh, it was supposed to be like a sort of assignment to optional assignment to test if you guys uh, were able to really understand everything that I've been going through throughout these 9 classes. However, I was a bit disappointed because I didn't receive any submissions of possible solutions. However, I won't count that against you guys that much because I realized afterwards that the assignment was possibly a bit too hard and included part of the solution, the most optimal solution utilizes recursion. So even despite this, I still want to show you guys my solution to the project. It took me like 30 minutes or so. I could probably have done it live for you guys, but in order to like save time, I just basically did it beforehand. So here's my version. So first, I'll show you guys that it works. I did it on BlueJ, so I'll compile it and I'll clear it from before. I cleared my board. The reason there was some stuff in my terminal window is because I tested it earlier. So, okay. So how it works is basically you can choose a row and a column to place it based on using coordinate system basically. The columns and rows vary from 1 to 3. For example, if I do 2, 2, it'll be placed at the center. And I don't know, I'll do the pretty standard way of winning real quick. Wait, I think I messed it up, but oh well. So this was the tie case. As you can see, no one won, so it was a tie. And if I do 1, it allows me to play again. And I'll show the case in which the player is able to win. So if you see here, this is the case in which the player wins. And also, if you do an invalid input, for example, if the row and column is outside of 1, 2, 3, it says it's invalid. And if you place an X in a place that has already been taken, it also tells you it's invalid. So that basically checks to see that everything works as I described in the project description. So now I'll show you my source code for it. Yeah. So it's actually quite long, but most of this code is like copy and paste stuff, and yeah. So scanner input here, I create this so that we can take the input from the user, like for example, playing again, or like the column and rows to place numbers. Here, I create the tic-tac-toe. This is the main function in which we call different methods that we create to run it. So I'll talk about the first few methods I create. This is the display board function. Given a array of values of X and O in each of the boxes, it displays the board. And I did this using a for loop to simplify it, but if you really wanted to, you could just display it as normal, writing with like 5 system print lines. Here's the main function, which is allowing the player to move the O and the player to move an X. There are two different functions, but they're copy and pasted. They're the same basically. See, player move X and player move O. So given in parameter of the 3x3 array of board markings, we create a copy of it so that we can manipulate it, because changing position of changing the value of the parameter directly does not change it, because it refers to the same position, but it isn't. It's basically a copy, so nothing actually changes when you call upon it. So we have to create a local version of it, which we do here, and we set it equal to the parameter, so it's the exact same. We basically create a local copy of it, and then we allow the user to input a row and column value, and given that, we first determine to see that it satisfies the boundaries of 1, 2, 3. Because if it doesn't, then it doesn't really mean anything, because there are only 9 board positions, and we tell the user if it is invalid. And here's where the recursion comes in. If it is invalid, we will force the player to move again. So we call this function again. See, the process of calling a function within itself is what we refer to as recursion. So with this in mind, if it keeps on calling itself until it receives a position that is both not taken and within the constraints of the column and the row. And if it does, it prints the board with the position changed, and it also changes the string array to reflect that. Here we check on the win conditions, basically 3 in a row. There are 3 in a row, either horizontally or vertically, where on the diagonals it says the game has been won. And here's the main function. So the while true here allows the player to keep on playing the game until you could remove the if in the first else if and make the second else if to an if. Wait, where? Here? First the if and the first else if. I mean, you could. In a lot of cases, if and else if are sort of interchangeable. But in general, if you can, you should use an if and else if statement, or otherwise use a switch function, because an if function is checked each time going through the loop, but an else if is only reached if the if statement is reevaluated to false. So the most efficient way of checking things, especially only with like one or two conditions, is to use an else if statement. Although an if statement certainly works. So when we create a new game, we set the counter to 0. We basically reset the board as well, and we display the empty board. So counter here allows us to determine when there is a tie, because there are 9 positions on the board and 9 spaces to fill. If the game runs 9 times, 9 moves are made, then it's automatically a tie, which we have here. If counter reaches 9, it's a tie. Otherwise, in each of the positions, O always moves first. So starting from 0, 0, 2, 4, 8, and X always moves second. So on the odd number of positions based on our counter. Yeah, there's a Boolean array. It works the same. You can use a Boolean array or even an integer array and use 0 and 1s or true and falses to represent O's and X's in the board. However, using a string function is more efficient because you don't have to, you can display the board directly basically. And then we check to see if the position change move makes a player win, and if it does, we break out of this while loop and we say that the player wins or whatever. So after a player wins, where if it's a tie, we print the message, press 1 to play again. And if 1 is not pressed, if you press 0 or 2 or something like that, then the game, we break out of the while true loop, the forever loop, which basically is the same as like quitting out the game or something like that. Another thing is we utilize the function return method to update the position directly, and that's a interesting application of the return function of a method. So this is the code I have. Basically the official solution or whatnot to the assignment I assigned last time. And certainly there are probably more solutions out there, perhaps more efficient, but this is definitely a good way to go about doing this project that is intuitive and simple and not too long. So does anyone have questions about the solution to the project below? Should I post this code onto the slide or something so it's easier for you guys to view for the future? Okay. A few people are saying yes, so I'll do that after the class is over. Also, when I post the slides onto the Google Classroom, are you guys able to view them? Okay, great. Okay, so now that we have seen one of the reasons to use a recursive function, or an example of it that serves as an adequate introduction to the importance of recursive methods within Java. So I'll go back to my slides. So the definition of a recursive function is, okay, I'll first define a recursion, which is the process in which a method calls upon itself repeatedly. And when a method does this, it is called a recursive method. So the example of recursive method from the previous project would be the player movement, the player moves O and player move X functions because it calls upon itself repeatedly until the player moves makes a valid move. And as we can see here, the recursive method can be a fixed number that stops based on a counter value, for example, or it could be something that depends on the user. In the case of the last function, whether or not the user inputted a valid number for the rows and columns of the tic-tac-toe board. And here, I put a picture that I felt really illustrated the definition of recursion. It says, to understand recursion, one must first understand recursion. And it's a quote by Stephen Hawking. And I thought it was kind of interesting because this in itself is a recursive function, kind of. Basically, if you understand recursion, then you're able to understand recursion and calls upon itself, kind of. I don't know. It might be a poor example, but I thought it was kind of interesting. So, why would we use recursion? Well, as we saw in the previous project, one of the reasons to use recursion would be to force the user to make a valid input. And it's useful for any sort of repetition within a program. Like the repetition could come from the user repeatedly making invalid statements, or a repetition in like calculating some really large value. And when we see any sort of repetition, we should think of using recursion because it calls upon the method and prevents us from having to write a lot of methods where calling upon the method manually a lot of times. In addition, we want to talk about the difference between iteration and recursion. From the image we see here, this kind of illustrates the difference between an iterative approach and a recursive approach. For the iterative approach, it is usually represented by the for loop, in which we loop through values 0 to like n. Like, for example, if we wanted to repeat something 10 times, we would do int I equals 0, I less than 10, I plus plus, in which it goes through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and therefore repeats the same function 10 times. That is an iterative approach. And in our example here, it would be like, for example, if we have a pile of boxes to sort through, we would keep on grabbing a box based on the for loop. And if we find another box, we just add it to the pile, making it another box that we would have to search. And if we find the key, we're done. And the recursive approach is very similar. However, there is no like initial restraint to it. What I mean by that is that it's not like the for loop in which we know how many times it runs necessarily. For example, for a user input, it could run repeatedly until something happens. And that is sort of the way reflects how the while loop works. And for my example here, basically it goes through every item in all the boxes until it finds the key. And if it finds the key, we basically break out of it. And why the recursive approach, as we can see here, is better sometimes is that it is more intuitive and it's more legible. Certainly having this sort of logic is less convoluted than having a bunch of if statements within a for loop. And yeah, and the something that comes along with this sort of innate simplicity is that it decreases the code length. For example, if we see my function here, where I use a recursive function 3 times, If I did not call upon the function itself to do this, I would have to do an iterative a method, and that could probably like make it so that my code is like 5 times longer or something like that, which would be inefficient and uh, less simple for the user to understand. So does anyone have any questions regarding how recursion is helpful to us and why we should use it and the definition of it? Basically everything I've gone through so far. If you have questions, feel free to like let me know. I'm not sure if you guys aren't asking questions because this is like something that's too simple for you guys, or if you guys are just too confused, like just with everything that's been going on so far. But I guess I'll move on because you guys aren't saying anything. So hopefully it's the first case in rather than the second case. So now I'll describe the basic thought process behind how to use recursion. So we use a 3-step process. Whenever we want to generalize some process, using steps makes it easier, allows us to simplify it, whatever. So the first thing to consider when doing recursion is to determine the base case. And what the base case here means is what happens when we call the method once. So in our case here, the base case would be if none of the recursion is needed, and that would be the best case scenario. The base case would be when the player chooses a position that has not been taken and is also within the boundaries of the board itself. That's our best case scenario. Then we move on, right? We change the position that the player chooses and we display the board. We move on. That's the base case because it's what we are looking for. And what happens initially when no recursion is used. Second thing to determine is where and when and why the message should call upon self. I'll use the same example as my introduction and look to answer these 3 questions. So where? Okay, so first we have to understand why or what the need for recursion comes from. For my example, it's pretty simple. If the user chooses an invalid position, the board still hasn't been filled yet, right? So obviously we still need the user to ask the user to make a correct move. So accordingly, where we put it would be to after telling them that the position is invalid. Because if we tell them the position is invalid, we obviously need a new position from them. So we would put it after that. And as you can see, we do that in every scenario that comes here. And we also know, kind of answering the one question, we know to use recursion here because we need to repetitively ask the user for a new position until a valid position is given. And whenever we see the word repetitively or many times, we have to ask ourselves if we need to use a recursive function, a recursive method, or something we've talked about before, the iterative method, which involves for loops and while loops. Okay, so on to our third step. Once we know when the method should call upon self and repeat, we have to determine a stopping method. Because if we don't determine how the recursive method is able to stop, it becomes like a while true loop. That means it repeats ad infinitum and never stops. And the reason this is the problem is because if it's in the middle of a code and it doesn't stop, that means it will never pass that recursive method and your code won't be able to move on. And second of all, even if it's at the end, you still have to stop in order to stop the code from running, taking up resources, RAM, whatever, and to output your desirable solution. And now that we know why we need to stop, it's important to determine the stopping method. As before, I'll go back to my introduction for simplicity because you guys are probably more familiar with this code and example already. So for my example, the stopping method would be this column of this row of if else statements. These if statements check for when the position is valid, and as soon as the position becomes valid, it stops by no longer calling upon the method itself, and that sort of breaks the repetitive recursive loop. And as I said before, but I want to reiterate, recursive algorithms can generally be replaced with iterative algorithms. And I'll give an example of how you can do that here. For example, if I didn't want to use recursion, I would have to do something like, I could create a flag that says while true, I have to repeat it. And once a valid position is given, I would change the flag to false. And I would break out of the while loop, allow the function to move on, and whatever. So that would be the iterative way of using a while loop to achieve the same task as a recursive function, but with less intuition behind it. So does anyone have any questions regarding the logic of how to use the recursive function and recursion in general? No questions? All right, and again, I have you guys muted, so if you have any questions, just as a reminder, you can always press the chat button and you can send me messages. So that's the medium in which you guys can ask me questions. Just in case you guys aren't aware of that already. I think I said that before, but yeah. I'll move on now, but if you guys still have any questions, feel free to ask me anytime. I'll answer it to you, and yeah. I'll move on now, though. So, perhaps you guys might have some questions about recursive functions still, or how they differ from an iterative function. So that's why I want to show you guys an example. So, I'll show you guys the difference between the iterative and recursive methods for creating a function that determines the factorial of a positive integer n. So hopefully you guys know what a factorial is, but if you don't, a factorial is basically for any positive integer n, a factorial determines this like n factorial would be like n times n minus 1 times n minus 2 all the way down to 1. I don't know. I'll give you an official definition real quick. the official definition here is a product of an integer and all the integers below it up till 1, I guess. For example, 4 factorial would be 4 times 3 times 2 times 1. So I'll show you how to do the iterative and recursive way of creating a function to calculate the factorial of a number n. So they're relatively simple, so I'll use REPL. Okay, I'll first do it the iterative way because that is what we're used to. So we create a method to calculate the factorial. We want it to return an integer, the value of n factorial. And we call the function, I don't know, factorial. So the iterative way is pretty simple. We use a for loop. Oh, shoot. Okay. So we can see that this function works. 4 factorial is indeed 4 times 3 times 2 times 1, which is 24. And this would be the iterative way of doing it because we go through each of the values 1 to n, and each time we multiply it to our value of factorial before. We do not see any case of us calling the function itself or whatever, so it would not be a recursive function. Now, I'll show you guys the recursive method of doing it. Recurse. So we keep in mind the 3 steps to solving a recursive method. First, we want the base case. The base case for a factorial would be when n equals 1, because we can't go down from there anymore. We can't multiply by 0 for some example. So it would be, we create an if statement. If it's the base case, we're done, basically. That would be our stopping criteria as well. So now that we're done with that, we want to figure out how and where to use the recursion. Uh, Therefore, for everything other than the base case, we would return n times recurse of n minus 1. What are we doing right now? I talked about recursion today. Mostly, you might have missed some of that. I'll post the slides on the Google Classroom. And yeah, so I'm showing the difference between the iterative and recursive methods of creating a function. Oh wait, shit. To Okay, so I'll test my recursive function. Wait, I did 7 by accident, should be 4. Yeah, the meeting ends in 1 minute. But yeah, so both of these clearly work, and you can see why this would work, right? Each time until we reach 1, it would just multiply n to the function, and when we reach 1, we no longer recurse. So yeah, for example, if it's like 3, 4, it would be 4 times recurse 3, and recursive 3 would be recurse 2 times 3, and then all the way to 1, so it'll be 4 times 3 times 2 times 1. And Edward here sent me his solution, and it would definitely work. His recursive solution is definitely correct. So that's great. Any questions?